quick one. On most chips, when you look at the top, and this is the top of the chip, you're looking straight down at the board. Most chips will have a little horseshoe indentation or a little horseshoe cut out there, or a little dot over here. They may have both. That is to tell you this is pin number 1. If that is pin number 1, then you count 2, 3, 4, 5, 6, 7, and continue right on around 8, 9, 10, 11, 12, 13, and 14. All right? Once you find out where pin 1 is, you just count counterclockwise. Of course, remember now, if I turn the chip over, this is the bottom. All of a sudden it reverses. This is pin 1. This would be pin 7, 8, and 14. By the way, this holds true even if the chip has 16 or 20 legs. You count down the one side and around the other. Okay?
Question. On a 7-lead project 2.
A 7-segment LED?
Yeah.
Yes.
How do we go about measuring for where?
Same thing.
Positive.
Because on what he's referring to is on one of the projects we use a standard 7-segment LED, which is nothing more than a little clock radio, a little digital display. All right. It also has 7 legs. 1, 2. I don't remember exactly. Something like that. I'm trying to remember how many there are. There are some legs missing on the device, but you do the same thing. Look for the decimal point. That tells you that you're looking at this the right side up. This is the top. And so this is pin 1, 2, in my case, 2, 3 is missing, so this is 4, 5 is out, here's 6, 7, 8, 9, 10, 11 and 12 is missing, and 13 and 14. All right? So you count them exactly the same thing. You just, there's chips, there's legs missing, but counted as though they're there.
So one is input.
Yeah. Well, according to what configuration you have as to which one is the common leg. I'll go over it with you and show you.
You just lost me.
What?
Just in saying that, because I ended up having to look at everybody's board, and they didn't know, and they had to go and look to see where the wires are coming in, and no one knows just right off the top of it.
Well, there are some.
Is there a means of measuring?
Yeah.
That's the part I'm interested in.
Well, the problem, and what he's talking about, is these little 7-segment LEDs. Every manufacturer builds his just a little different. The only saving point is the fact that they count this the same way. This is called segment A, B, C, this is data point, or decimal point, D, E, E, F, and G. So luckily, they at least stuck with this. Now what you don't know is what pin though is going to light up segment A. And here again, I know some of you, this doesn't make any sense, but it will real quick. So you have to look at the unit you have and do some testing, right, as to which one's going to be segment A and then which one is the common leg. I'll show you on those.
Yeah.
We'll sit down and go over it. All right.
Something we should be familiar with?
Well, how to find it. Don't worry don't try to memorize which pin or anything because they change. But how to find it is important.
Right.
Right. Okay, so this shows a lot of how to identify the different components. The next one is this wheel here. And you can label this something called Ohm's law. Anyway, that is Ohm's law. That's OHM. As a matter of fact, this is named after a gentleman called Ohm. That was his name. Back in the 1700s, he did a lot of experimenting with electricity. So if you think electricity is something new and different, it's not. It's been around for centuries and centuries. It's just we have finally learned how to control it and really do something with it. Electricity, and I'll throw this in, electricity without control is nothing more than lightning. Lightning's electricity, but it doesn't do us any good because we can't control it. So same thing, electrical or electricity is absolutely useless to us until we can control it and put it to use. Anyway, Mr. Ohm put a lot of this to use, and what he came up with is this, although it looks really strange. And what he said was that in electricity we have three things that we worry about. All right? One we've just talked about, and that's resistance. Resistance. The other thing we worry about is voltage. And the other thing is current, or amps. And unfortunately, and this is another one of those, they use the letter I. And I'm going to put this out here, amps. 2 seconds and I'll be finished with talk. Didn't realize it was there. Anyway, he just said these are all relative to each other. And the relative value is that if I increase the resistance, I'm going to decrease the current flow through the system. Same thing, we were talking about the water pipes earlier. If I choke down on the water, you know, when you're watering your lawn, if you turn that nozzle down, you're not going to get as much water out the end because you've increased the resistance. All right? So there's a variance to it. And if I wanted to water my lawn more, I could get a bigger hose, let more water run through it. Or I could turn the pressure up. So these are all relative to each other. And that's what that chart's about, and we'll use it. We'll show you how it's used. All right? Okay, guys, that's it. Mike, thank you for showing up today. I'll see you tomorrow. We'll go over this.